Hi everyone, I am Mrs. Fitzpatrick and we are going to do a lesson today on roots and zeros of polynomial functions. So the first thing that we need to talk about is what do I mean by zeros? So what I mean is we have zeros of polynomials at any points in which the function intersects the x-axis. So basically x-intercepts. We end up having a lot of different words for x-intercepts when it comes to polynomials. We can think zeros. Sometimes we even call them roots. Think of like roots in the ground, right? You dig, and you can think of like the x-axis as ground level, right? So it's where it passes through the x-axis. A polynomial function of degree n can actually have at most n real zeros. An even degree polynomial has an even number of zeros or no zeros. Now, this is counting duplicates, and we'll talk about what I mean by that when we get a little bit further on in the lesson. Because you can have some, for example, like x squared equals 0. Technically, there's only one answer for that, right? But it's x times x, so we double count that as 2 zeros. We'll get into that. An odd degree polynomial has an odd number of zeros. Okay, so let's take a look at a graph of a polynomial. So the first one is f of x equals x cubed plus x squared minus 2x. And here we're going to be asked to graph the polynomial. Well, the first thing I do whenever I'm graphing a polynomial is I like to look at the leading term. In this case, it's x cubed. So it's a third degree, which means it's odd, and the leading coefficient is 1. So that automatically gives us the end behavior. So it means to the right, my graph should be going up towards positive infinity, and towards the left, it is going down to negative infinity. Now we need to figure out what's going on in between. To do that, I'm going to go ahead and set up a table. So I have x, I have f of x, and I'm going to go ahead and fill in this table of values. We'll go -3, -2, -1, 0, 1, 2, and 3. Okay, so you're welcome to use a calculator to help you get this table set up. So we're going to go ahead and quickly type these in. When we plug in -3, we get out -12. When we plug in -2, let's see here, -2, we get out 0. Okay, zeros, keep that in mind. When we plug in -1, we get out 2. When we plug in 0, we get out 0. There's another one. When we plug in 1, let's see what we get. We get 0 again. Wow. When we plug in 2, let's see what we get. We get 8. And when we plug in 3, let's see what we get. We get 30. Okay. So now what we're going to do is scale our graph. I'm going to scale the x-axis by 1. So 2, 4, 6, 8, 10. -2, -4, -6, -8, -10. All right, and then I'm going to go ahead and scale. I think we can still scale by ones here. So I'm going to go 2, 4, 6, 8, 10, -2, -4, -6, -8, -10. Okay, so now I'm going to plot the points that I know. So I do know that we have -2, 0, which is right here. We have -1, 2, which is right here. Then I have 0, 0. And then I have 1, 0. Then I have 2, 8 right up here. And it's going to go up. So this is kind of what my graph is looking like. So now we know on this side, it goes down to negative infinity, right? It's going to kind of have a small hump to go back up to positive infinity on that side. All right, now this is probably not the most accurate graph in the world. This is just the best we can do with what we have in Algebra 2 for right now. But what it does show us is the places in which our graph intersects the x-axis. So we do have some zeros here. In fact, this is a third-degree polynomial that has 1, 2, and 3 zeros. So the way we write that is our zeros are at x equals, and we use our curly braces. We have 1 at -2, so we use the x values. We have 1 at 0, and we have another one at 1. So we have 3 zeros for our third-degree polynomial. In this case, we had exactly 3 for a third degree. Okay, so what I'd like you to do now is go ahead and pause this video and try number 2. You can check your work using my solutions that will be on my website or Google Classroom. I'll post them to both. Okay, let's take a look at this next bit. So we're going to talk about linear factors. So factoring, it's not going away anytime soon. The linear factors of a polynomial reveal its zeros. Linear factors can be found by writing the polynomial in factored form. So we always, when we're factoring, start by looking for a GCF. So let's take a look at this example. We have f of x equals x cubed minus 2x squared minus 15x. Looking at these 3 terms, these all have an x in common. So I'm going to go ahead and factor out the x. So I have x times x squared minus 2x minus 15. Okay, well, the next step, I have a quadratic. So what I'm going to do is look for 2 numbers that multiply to -15 and add to -2. Well, it looks like -5 and +3 will work. So f of x equals x times x minus 5 times x plus 3. Now to find the zeros, we want to know where this intersects the x-axis. So all we have to do is set it equal to 0. So x times x minus 5 times x plus 3 equals 0. From there, we can use what's called the zero product property. So either x equals 0, or x minus 5 equals 0, or x plus 3 equals 0. I'm going to add 5 to both sides here. I get another 0 of x equals 5. And over here, by subtracting 3, I end up with x equals -3. So this is another cubic that gives us exactly 3 zeros. So I have x equals 0, 5, and -3. Okay. So now that we see how to solve for zeros, we just have to factor and set everything equal to 0 and solve. We've done this before with quadratics. Now we're going to go ahead and talk about what's called multiplicity. So multiplicity of a 0 is equal to the number of times its corresponding linear factor occurs. All right, this seems kind of like a fancy term for if you have a factor that's repeated, the number of times it's repeated is its multiplicity. So let's take a look at this example. We're going to go ahead and factor it. Once again, we always want to look for a GCF. So I see x cubed, -6x squared, and 9x all have a factor of x. So let's go ahead and pull that out first. F of x equals x times x squared minus 6x plus 9. Well, from here, we're going to go ahead and factor x squared minus 6x plus 9. We're looking for 2 numbers that multiply to 9 and add to -6. Well, -3 and -3, right? -3 times -3 is 9, and -3 plus -3 is -6. So this equals x times x minus 3 times x minus 3. Notice the factor x minus 3 is repeated twice. And you could even write this as f of x equals x times x minus 3 squared. So here we're going to go ahead and set x equal to 0 and x minus 3 equal to 0. Add 3 to both sides. x equals 3. So the zeros are x equals 0. This, because it's only repeated once, has a multiplicity of 1. And x equals 3 is another 0, but this has a multiplicity of 2 because it's repeated twice. Notice x cubed, it's a cubic, a third degree, it actually only has 2 zeros. But technically, it has 3 if you count that duplicate, right? So that's what I meant by the duplicates. If we count them, then we can have our n, right, roots. They're just not unique, right? Okay, so let's see what this does to our graph when we start graphing these, the cubics that might have different multiplicities for their zeros. So we're going to go ahead and graph x cubed minus 6x squared plus 9x. So we're going to do the same thing. Let's go ahead and make a table. We do know that this is going to have the same n behavior as the last graph we did because it's a cubic, so it's odd, and it has a positive coefficient, so it's going to go up to the right and down to the left, and we need to figure out what is happening in between. Okay, so it's x cubed, and we have what? Minus 6x squared. Sorry, I'm just typing this in so I can make this a little bit faster for the video, plus 9x. Okay, so we're going to go ahead and make our table. We're going to start at -3 again. -1, 0. And yes, I know this is incredibly inefficient, but with our math skills that we have now, this is kind of the way we have to do it here. So when I type in -3, we get an output of -108. When I type in -2, I get an output of -50. Lots of big values right away. When I type in -1, we get -16. When I type in 0, let's see what we get. Oh, well, this one's easy, right? We get 0. When we type in 1, we get 4. When we type in 2, we get 2. And when we type in 3, we get 0. I'm going to do 4 just so that I can make sure that we are on the right track. So when you plug in 4, you also get 4. So I'm going to make sure to include that point on my graph. Okay, so I'm going to go ahead and scale this very quickly. I'm just going to go by ones. Let me zoom in a little bit to make that a little easier. Okay. So you can see, just looking at our table, we're going to have 2 zeros. And I'm going to show you when you factor this. Actually, I think it's the same one we just factored, right? So when you factor it, this factors to x times x minus 3 squared, right? So let's see what that duplicate, the squared, does to our zeros. So let's go ahead and plot these points. We have -2, -50 is not going to fit on there, but -1, -16, still not going to fit. But if we start at 0, 0 here, we know this is going down to -infinity, right? So we have 1, 4. We also have 2, 2. And then we have 3, 0. And then we have 4, 4. So it goes back up. So let me show you what that looks like. See how at 0, 0, it actually is going to pass through the x-axis? And then notice over here at x equals 3 on the x-axis, it has to rebound back up. And in fact, that's exactly what happens. It's going to rebound off the x-axis back up, okay? So when the multiplicity is odd, like x equals 0 has a multiplicity of 1, then the graph crosses through the x-axis, and I'm going to put in parentheses the x-axis, at that 0. If the multiplicity is even, then the graph bounces off the x-axis at that 0. So see how it did here at 3, it bounced off, whereas the other one crossed right through. Okay, so what we can do now, if we have a factored polynomial, we can jump right ahead, solve for those zeros, and know exactly what our graph is going to look like at those particular zeros. So let's take a look at number 6. We're going to set each of those factors equal to 0 to find the zeros. So I have x plus 7, x plus 7 equals 0, 2x plus 1 equals 0, or x minus 4 equals 0. We're going to subtract 7 from both sides. We get x equals -7. Subtract 1 from both sides. 2x equals -1. Divide by 2. X equals -1/2. And then we're going to add 4. We end up with x equals 4. So we have 3 zeros. We have 1 at -7, 1 at -1/2, and 1 at 4. The multiplicity, remember, is the number of times that factor is repeated. So looking at x plus 7 squared, that is repeated twice, right? Because it's squared. 2x plus 1, well, it's to the first power. It has a multiplicity of 1. X minus 4 cubed has a multiplicity of 3. So if it's an even, it's going to cross through. Whoops. So the only one that's gonna, or sorry, if it's an odd, it's gonna cross through. So the only one that's gonna bounce, that's an even, right, is -7. So -7 is gonna bounce because it has an even multiplicity, whereas 1 and 3 are gonna cross the x-axis. The multiplicities of 1 and 3. So at -1/2 on the x-axis, it's going to pass right through. And at 4 on the x-axis, it's going to pass right through. Okay, I'm going to let you do number 7 on your own. You do have to factor that one. Don't forget to look for the GCF. And then we're going to do number 8 together, and that's going to be the end for this video. I will have you do one more thing for classwork before you're completely done, but let's go ahead and look at number 8. It says a polynomial function has a 0 at -6, multiplicity of 2, and a half multiplicity of 1. Write a polynomial function in standard form that could represent this function. Okay, so if it has a 0 at -6, it means at some point when you were solving, you end up with x equals -6. If you end up with a half as an answer, somewhere you ended up with x equals a half. Let's go ahead and reverse engineer what the factor would have to look like. If I add 6 to both sides, we end up with x plus 6 equals 0. That's my first factor. For this one, I could multiply both sides by 2. 2x equals 1, subtract 1, and 2x minus 1 would equal 0. That would be my second factor. Now, the polynomial function that would work for this, if -6 has a multiplicity of 2, it means it was x plus 6 squared. The factor was repeated twice. And then 2x minus 1 just has a multiplicity of 1. Now let's go ahead and write this in standard form. So I'm going to expand this polynomial by multiplying through. This would be x plus 6 times x plus 6 times 2x minus 1. And we're going to FOIL. First, x times x is x squared. Outside is x times 6 is plus 6x. Inside would be another plus 6x, so that's plus 12x. And then 6 times 6 is 36. And times 2x minus 1. Now we have lots of distributing to do, so let's jump in. We have x squared times 2x is 2x cubed. X squared times -1 would be minus x squared. 12x times 2x is plus 24x squared. 12x times -1 would be negative 12x. And 36 times 2x would be, let's see, 60 plus 12 is 72x, and then minus 36. Let's just go ahead and combine like terms, and our polynomial will be 2x cubed. We have negative x plus negative x squared plus 24x squared would be plus 23x squared, and then negative 12x plus 72x would be a positive, let's see, 60x, and then minus 36. So this polynomial has two zeros. One is at x equals -6. The other one is at x equals 1/2. And the one at x equals -6 has a multiplicity of 2, and the one at x equals 1/2 has a multiplicity of 1. Okay, so there's one more page I would like you guys to complete for notes, and that is this page right here. What you are going to do is graph x cubed plus 6x squared plus 8x using the strategy we've been doing, and I'd like you to fill in all of the information about them, including domain, range, end behaviors, zeros, all of the information, because we're going to start putting together all those pieces that we've been learning along these lessons together with all polynomials. All right, thank you guys. I hope you have a great rest of your day.